Hi guys, I am Julius A. Serrano, BSAMT student from University of Perpetual Help School of Aviation. Now this subject is Airframe Systems, section 15114. Now, I'll be discussing with you the areas and effects of ice formation. Now, before I start guys, I'd like to give you an introduction about the topic. When we say ice is a water in frozen solid form. It often forms on bodies of water like lakes, rivers, and ocean. But in this case, we'll be dealing with the ice formation on the aircraft. Now, formation, by definition, it is the action of being formed or forming. Now we have ice formation, but what are the factors that affects ice formation? Ice formation is caused by the coldness acting on moisture in the air. And based on my research, the troposphere layer of the Earth has a temperature ranging from 15 degrees Celsius to negative 60 degrees Celsius. And the stratosphere layer of the Earth has a temperature ranging from negative 51 degrees Celsius to negative 15 degrees Celsius up the top. Typically, modern aircraft flies up to 38,000 feet, which if we convert into kilometer is equals to 11.5 kilometer above sea level. And that is the lower portion of the Earth's stratosphere. And also, that is the reason why there is an ice formation during flight. Now, before we move on to the main topic, let me add some information that will help you further understand what I am discussing. Now, Newton has a third law of motion where it says, in every action there's a reaction. And this law is the reason why there's a four forces acting up on an aircraft. And that four forces are thrust, drag, lift, and weight. The thrust is being generated by the engine, and that is the forward motion. And the lift is being generated by the wings and the airfoil section, and that is the upward force. And the downward force is the weight and is being generated by the Earth's gravity. And lastly, the drag, which is the resistant force. And that force opposes the forward force of the aircraft. Now, going back to the areas that needs to be protected from ice formation. The following areas are critical areas of the aircraft where ice forms and ice protection is essential. Now, first, all airfoil leading edge of the aircraft. What happens when there's an ice formation on this part of the aircraft? This destroys the smooth flow of air over the wing, leading to severe decrease in lift and increase in drag. And next is engine air intakes. Ice accumulation on this part of the engine blocks the warm air that should be entering in the engine, therefore causing high fuel economy and decrease in thrust because of the messed up fuel and air ratio. Okay. Next is the windscreen. Ice formation on this blocks the pilot's view, leading to poor judgment of the situation and the weather. Propellers. Propeller also has an airfoil section, and the ice on this part of an aircraft produces a distorted blade airfoil that causes a loss in propeller's efficiency. Now, pitot-static pressure heads. When dynamic air pressure cannot enter the pitot tube opening, it or it inaccurately operates, the same with the other two static instruments, which are the altimeter and the vertical speed indicator. Now let's talk about the effects of ice formation in general. Again, the buildup of ice on the aircraft is called ice accretion, which in simple terms, formation. From the foregoing, it is evident that if ice continues to be deposited on the aircraft, one or more of the following effects may occur. Now first, decrease in lift. May occur due to changes in wing section resulting in loss of streamlined flow around the leading edge and top surface. Next is increase in drag. Due to rough surface, especially if the formation is rime, this condition results in increased surface friction. Increased weight and wing loading. The weight of the ice may prevent the aircraft from maintaining height. That's just basically it. Decrease in thrust. Now, with turboprop and piston engines, the efficiency of the propeller will decrease due to alteration of the blade profile and increase in blade thickness. Vibration may also occur due to uneven distribution of ice along the blades. The gas turbine engines may also be affected by ice on the engine intakes, causing disturbance of the airflow to the compressor. Furthermore, ice breaking away from the intake may be ingested by the engine, causing severe damage to the compressor blades and other regions within the engine. The next is inaccuracy of pitot-static system instruments. Now, as I've said earlier, ice on the pitot-static pressure head causes blockage in the sensing lines and produces false readings and inoperable instruments. The next is loss of inherent stability. This may occur due to the displacement of the center of gravity caused by the weight of the ice. Next is the radio antennae. When ice forms on this part of the aircraft, the radio has a reduced efficiency. Loss of control. Loss of control may occur due to ice preventing movement of control surfaces. This is not usually a problem in flight but may occur on the ground. Now, let us discuss the effects of icing on the ground. The effects of ice accretion on the ground is just similar to those occurring while in flight. But the following additional effects may be caused. First, restrictions of the controls may occur if ice is not removed from the hinges and gaps in the controls. Second, the takeoff run may be increased because of the increase in weight and drag. The same with the third, the rate of climb may be reduced because the weight and drag are increased. Now, guys, that is all, and thank you so much. I hope you enjoyed my discussion and I hope you learned something from my video. Thank you guys, and God bless and stay safe.